To those who don't know this channel, I'm a former geologist who's been a science journalist for 25 years. My YouTube channel debunks all kinds of scientific urban myths. So here, a summary of the most common misrepresentations of science we've come across over the years regarding climate change, and the real science they're misrepresenting or omitting. Let's start with a famous myth about the name of the subject we're talking about. No, first of all, they started with global warming because they wanted to focus on CO2, and they started talking about climate change. That's why they call it climate change now and not global warming. No, it goes back a lot further than that. The conclusion that CO2 concentration affects global temperature was made 120 years ago and confirmed in the 1930s and 40s. In the 1950s, it became known as the carbon dioxide theory of climatic change, or climate change for short. This paper was written in 1955. That's why back in the 1980s, we saw the formation of something called the Intergovernmental Panel on Climate Change. The term global warming describes the global warming that causes this climate change. Climate changes all the time. It's a very natural thing. Climate change is a natural phenomenon that always will be. The climate change has always been occurring. How do you explain climate change that occurred 10,000 years ago before man had a carbon footprint? Because of course it's not the mere presence of humans that's changing the climate, it's carbon dioxide. We know why carbon dioxide concentration is rising now, and geologists know why it rose in the past. First of all, let's get one thing clear. The main active drivers of global temperature now are exactly the same as in the past, long before humans came along, which shouldn't really be a surprise, because the laws of physics haven't changed. They are threefold. Changes in solar irradiance, which is the amount of heat we receive from the sun, changes in carbon dioxide concentration, which traps that heat, and changes in aerosol concentration, which reflects that heat. Just to anticipate a few other myths that I'll cover later. Things like water vapor content, cloud cover, and ice albedo respond to these changes in temperature, but they aren't the primary causes. And although winds and oceans move the heat around, they don't significantly change the temperature of the Earth, so they aren't active forcings either. So how did carbon dioxide levels change before factories and subs came along? Well, let's start at the beginning of the Phanerozoic about 500 million years ago, when CO2 levels were nearly 20 times higher than today. Over hundreds of millions of years they got taken out of the atmosphere by chemical weathering, which turns the carbon dioxide into calcium carbonates and deposits it as sediment in the oceans. So trillions of tons of CO2 that were once in the atmosphere are now locked up in limestone. The other way CO2 got taken out was when living matter got buried as coal and oil. But this gradual decline in CO2 concentration is punctuated by sporadic increases in CO2 during flood basalt events, occasional weaknesses in the earth crust that spill thousands of square miles of thick lava and release billions of tons of CO2 back into the atmosphere. So that brings us to the next myth. Since CO2 is a powerful greenhouse gas and CO2 levels were much higher in the past, why was the Earth sometimes colder? Here there was an ice age when CO2 was at least 10 times higher than it is today. The reason is very simple. The sun was much weaker back then. Over the last 500 million years there's been a slow and steady increase in solar output. So during the late Ordovician, the time period Patrick Moore is talking about, solar output was about 4 lower than today. So it's no surprise that the Earth was in an ice age. The question the critics need to answer is why was that the exception? Why was it much hotter than today for hundreds of millions of years either side of this brief age? And here we had almost 7,000 parts per million of Catu compared with 385 or thereby today. 7,000 then. 7,000 then 7. Temperature managed to get up to about 22 Celsius. That's the point. How did it manage to get up to 22 Celsius, which is 6 degrees hotter than today, even though the sun was about 4 cooler? There's never been an answer from the critics, but scientists explain it quite easily. Since Catu has a strong warming effect, it was this insulating blanket of Catu that kept the Earth warm. And researchers have found that the reason it cooled during the Ordovician was because a series of tectonic collisions led to a period of mountain building that sped up chemical weathering and took a lot of Catu out of the atmosphere. As Catu levels fell, the Earth cooled and triggered an ice age. Since the increase in solar irradiance has been very slow and steady over the last 500 million years, researchers have found that it's these sporadic increases and decreases in Catu levels that have largely driven global temperature. By the way, the graph Christopher Monkton is using is the same graph Patrick Moore was using, just in different colors. It comes from a blog. Catu levels compiled by a researcher called Robert Berner, shown in black, have been put alongside global temperatures compiled by Christopher Scottis, shown in blue. Scottis drew the temperature sketch nearly 20 years ago based on a book that's now 26 years old, so he's recently updated it. This is Scottis' more accurate and more recent reconstruction. And look at how little correlation there is in that graph between temperature in blue there and Catu concentration in black. And it shows very clearly that there's no lockstep correlation between Catu and global temperature. But there's no lockstep correlation between solar irradiation and global temperature either. But surely we can't conclude from that the sun has no effect on global temperature. Since there are three main active drivers of global temperature, you can't just ignore the other two. You have to look at all three. And when you do that, you get a very good correlation. You get a very good when you do you have a. Correlation doesn't necessarily mean causation, of course. So in this video I am not going to try to show you the evidence for the strong link between CO2 and global temperature. That's in another video we made. In this video, I'm just debunking the most widespread myths about climate science and the claim that there's no correlation is one of them. Now let's move forward in time to the present. And to do that, I want to give you an idea of the difference in time scale that represents. Let's take a walk up the Mississippi River from New Orleans to Memphis. That's 485 miles, so that represents about a mile for every million years of the Phanerozoic. It's a long walk that Google Maps reckons would take about a week non-stop. Only the last 2 miles represents our age, and the last 40 years of strong warming is just a couple of inches. That's the period of time we're going to be looking at in the next couple of myths. So what do you think is causing global warming? The sun. There's definitely no question. There's definitely no question. They virtually ignore the sun as a factor of climate change. The sun is driving climate change. CO2 is irrelevant. It's the sun so stupid. So why do climate researchers say it's not the sun? Because solar irradiance, shown here in blue, has been decreasing over the last 40 years, so it can't possibly have caused temperatures, shown in red, to go higher. The claim that the role of the sun has been ignored by scientists is also wrong. Scientists have devoted a huge amount of effort into monitoring the output of the sun and studying its effects on global temperature, both now and in the past. When I mentioned this before, people have been confused by the fact that the sun has been getting cooler over the last 40 years, when I've also said that for the last 500 million years it's been getting hotter. That's because of the difference in magnitude and time scale. Here's where the time illustration will help. Because the growing output of the sun represents our uphill climb from New Orleans to Memphis. We're reclimbing 308 feet, which is quite a lot. It's the height of the Statue of Liberty. That represents the 4 increase in solar output. But over 485 miles you wouldn't even notice it. The road looks pretty flat. What you would notice are the very small dips and inclines over short periods. Even this wheelchair ramp down from a sidewalk onto the road represents a decrease in solar activity over hundreds of years, similar to the little age. In other words, The tiny drop in solar irradiation over the last 40 years would go unnoticed when set against the huge rise in solar irradiation over the last 500 million years. And the other side of the coin is that the long-term rise in solar irradiation is so slow that it wouldn't even be noticed over a 40-year period. There are many more factors in play than simply the concentration of Cotto in the atmosphere. Factors such as the shape and size of the Earth, elliptical orbit around the Sun. Elliptical orbit as the soft lead scientist at NASA said this. He said that what ended this age was global wobbling. Is the wobbling of the Earth included in any of your modellings? And the answer was no. When you have a model and you say we're going to leave out the most important impact of that model out of our theory and not talk about global wobbling, how can you make projections? Because right now these wobbles are not affecting us. They're well known and very predictable. At the moment there's a very small change over a period of thousands of years, but for reasons we just explained this is too small to be measurable over a 40-year or 100-year period. The last time the Earth's wobble had a significant effect was about 15,000 years ago, and the next time will be at least 16,000 years from now. Now, one thing that kind of jumps out at you is, do they ever fit together? But looks can be deceiving. Al Gore is glossing over the fact that the start of each deglaciation was not caused by Cotto. It was caused, as we've seen, by a wobble in the Earth's axis and orbit that allowed a little more sunlight to hit the Earth. Over most of the Phanerozoic, these wobbles have no discernible effect. The change in global temperature is too small. But an ice age is different because ice has properties that amplify the warming far more than when the Earth is ice-free. When a small amount of ice melts, less sunlight is reflected back into space, and methane and carbon dioxide locked up in frozen soils and cold oceans are released, and that causes more warming. The amount of extra sunlight the Earth receives due to its orbital wobbling isn't enough to melt ice sheets the size of continents. What does that are the amplifying factors, as we'll see when we move on to our next myth, the complete opposite of the previous one. So here we're re-looking at the core record from Vostok, and in the red we see temperature going up from early time to later time at every key interval when we came out of a glaciation, and we see the temperature going up, and then we see the Cotto coming up. Cotto lags behind that increase. It's got an 800-year lag, so temperature is leading Cotto by 800 years. So obviously carbon dioxide is not the cause of that warming. In fact, we can say that the warming produced the increase in carbon dioxide. And that's correct. Researchers have found that carbon dioxide is not the cause of that warming. The critics err specifying that this happens at the end of a glaciation, and as we've seen, the little bit of extra sunlight the Earth receives at the end of a glaciation does indeed warm the Earth. As oceans warm, dissolved Cotto is less soluble and it's released into the atmosphere. Cotto and methane locked up in frozen soils is also released, and methane also breaks down into Cotto. So it's no surprise that at the end of a glaciation, which is the start of a period called deglaciation, Cotto lags temperature. The problem is that the critics assume this means that Cotto can only lag temperature, and that it therefore can't to be a greenhouse gas. But this focus only on the early stages of deglaciation ignores the fact that research scientists say that in the latter stages of deglaciation, Cotto leads temperature. Just ask the researchers who are accredited with making this graph, Nicholas Kahan et al. Here's the original graph in the paper being referenced by the critics. The authors explain how Catu lags temperature in the early part of deglaciation in the southern hemisphere, but it leads temperature rise during the rest of deglaciation in the northern hemisphere. The authors write, "This sequence of events is still in full agreement with the idea that Catu plays, through its greenhouse effect, a key role in amplifying the initial orbital forcing. That means the Earth swabble. Other researchers have found exactly the same thing. So telling us that Catu lags temperature rise at the end of a glaciation is correct. But it's only telling half the story, and sometimes the critics blur that. Catu clearly cannot be causing temperature changes. It's a product of temperature. It's following temperature changes. This is giving the impression that Catu only ever lags temperature. Lots of people have come onto my channel convinced that that's what the researchers have found. The positive feedback though isn't to go on forever, of course, because as the temperature of the Earth rises, it radiates more heat. So once the initial forcing has stopped, the temperature keeps rising until the amount of heat leaving the Earth balances the amount of heat coming in. The Earth then stabilizes at a higher temperature called the equilibrium temperature. So the longer it takes to stop the Catu forcing that we're re-experiencing now, the longer it'll take for temperatures to stabilize and the higher the final equilibrium temperature will be. How much Catu is up there anyway? 4 of that is due to man. Human activity contributes perhaps 3 of the 3. No, the figure is actually 10 times higher. It's around 33. How do we know? Because since the Industrial Revolution, humans have poured hundreds of billions of tons of carbon dioxide into the atmosphere, and researchers can measure where it's gone. About half has been dissolved in the oceans, where it's turned into carbonic acid, and about half has accumulated in the atmosphere. That's why after about 8,000 years of Catu levels between 260 and 280 ppm, the concentration has risen to over 400 ppm since the Industrial Revolution began 200 years ago. So where do the critics get this 3 figure from? 97 of all Catu emitted every year around the world is naturally caused. Only about 3 is from humans. We recreating only 3 of the Earth's Catu. The biggest source is air-decaying plants, volcanoes, and forest fires. But that's normal carbon flux. Since this is not explained, it leads people to believe the figure refers to the human contribution to the increase in atmospheric carbon dioxide. So what is carbon flux? Pence writes when he says the surface of the Earth is constantly expelling carbon dioxide in a variety of ways. But what he doesn't mention is that at the same time it's reabsorbing carbon dioxide in a variety of different ways. For every tree that dies and releases carbon dioxide, another tree grows and absorbs it. The ocean is expelling carbon dioxide, but it also dissolving carbon dioxide, and so on. So Catu is constantly cycling in and out of the biosphere. And for the last 8,000 years, since the end of the last glaciation, that recycling, called carbon flux, has pretty much been in balance. In other words, very little of this carbon in circulation accumulates and builds up in the atmosphere. The problem is into this balanced circulation system, billions of tons of extra carbon has been introduced from a new source, the burning of coal and oil that had previously been sequestered. About half of this new carbon has been matched by ocean and biosphere absorption. In other words, it simply joined the carbon flux cycle. But the other half has been slowly accumulating in the atmosphere since the Industrial Revolution. This is the that accumulation now comprises around a third of atmospheric Catu. So it's the accumulated Catu that has the warming effect. In my video are humans contributing only 3 of Catu, I show the difference between carbon flux and carbon accumulation using the example of two tanks of water. Water is going out of tank A into tank B at the rate of 100 liters a day. At the same time, water is being pumped from tank B into tank A at the same rate. The result is that the level in tank A stays where it is. But if we introduce water from a new source at the rate of 2 liters a day, that's just 2 of the water in circulation. It steadily accumulates. The level of water in tank A rises, and that's where the problem lies with CO2 accumulating in the atmosphere, and that's what's causing the warming. How do we know that the extra CO2 is from fossil fuel burning? Because carbon has 3 main isotopes, carbon-12, the most common one, carbon-13 and carbon-14. Unlike volcanoes, fossil fuels contain almost no carbon-13, and unlike plants, they contain almost no carbon-14. And life oil The evidence that the extra carbon that's accumulating is from fossil fuel burning rather than living matter or volcanoes is that the ratio of these Cm-13 and Cm-14 isotopes has gone down in the atmosphere and oceans. If critics still want to insist that the CO2 isn't from fossil fuel burning, then they have to explain how all this extra CO2 suddenly appeared in the atmosphere and oceans, and they have to explain where the hundreds of billions of tons of CO2 that humans have produced over the last 200 years has gone. Can global warming be happening as expected if the world has stopped getting hotter? The Earth basically has not been warming for the last 15 years or so. No, the Earth has continued to warm, and this has been confirmed by every single temperature monitoring body across the world in a number of different countries. It may be cold right now wherever you are, but these measurements are taken on a global scale, on the ground, in the air, and under the sea, and averaged over the entire year. Hundreds of people from dozens of different scientific institutes all over the world are involved in this process. Collectively and individually, they all show that despite lower solar irradiance and increased aerosol pollution, the Earth continues to warm. Well, maybe the temperature data has been faked, the critics will say. And even if there has been warming, it isn't as much as the models predicted. And even if it is, warming will be good. And didn't they predict an ice age in the 1970s? And aren't we expecting an ice age now because the sun's about to go dim? Yes, there were lots of other myths, I know, and unfortunately I can't cover them all in just one video. But I have covered them all in my climate change series, So take a look and see what the science has to say. But I hope the moral of this story is that if you want to call yourself a septic, that's admirable, but in that case be skeptical. If you retold there's no correlation between Cotto and temperature, then ask why researchers conclude that there is a link. Find out what it is they know that the critics don't, or that the critics aren't telling you. Instead of just accepting that the scientists must be wrong because someone tells you the sun is causing global warming, turn that into a question. How come researchers don't think the sun is responsible? Find out. And obviously, if only 3 of carbon dioxide in the atmosphere is attributed to humans, then we don't have a problem. So why all the fuss? What is it that the researchers know that the amateurs don't? Because either professional researchers are so incompetent that in 120 years of published research, they haven't spotted something so simple and obvious that even an amateur can post it in a YouTube video, or they know something the amateurs don't. Start by asking a question and finding the answer. As always, don't even believe what I'm telling you either. Check me sources, which are in the video description and shown on the screen, and see for yourself if the critics are telling you the whole story. That's the hallmark of a true skeptic. Thank you.